Hi there, you're welcome back to my channel. In this video, I'll be taking you through integration by substitution. This is the first technique of integration I'm going to take you through. So, I have two problems here to really explain this concept to you. So, please get glued to your seats and follow as I solve along. So, my first one, I have integral of 2x square root of 1 plus x squared x. One may ask, when do we use substitution? When we use substitution method? Substitution method is used when one function is the derivative of the other. Okay, so realize that these 2x is the derivative of what? X squared, right? Or is the derivative within this function. So normally when you are given two functions which you can simplify, probably a transcendental function and an algebraic function, right? Then it means that this is a radical function and this is a polynomial function. So here you can't simplify it anyway, right? So you realize that when I differentiate x squared plus 1, I'll get 2x. And this is where we use substitution, okay? So to use substitution, let u be equal to what you have under the square root, and that is going to be 1 plus what? X squared. Here I find my du over the x, and I'm going to get what? 2x, okay? 2x. So what do we do here? At this point, I made 1 plus x squared to be u. So I'll simply have to make my substitution. So 2x square root of u du, right? Square root of u du. But there is a problem here. There's a problem here. So I made u to be equal to 1 plus x squared. So that is du, or u within the square root sign. But this the x here. For me to replace the dx, I need to make the x a subject here, right? I can't just carry or make the u. No. I have to make the dx the subject here. So remember, if I cross multiply, I'll have my dx to be equal to 1 over 2. Here is what? X, right? U. Okay. So once you're able to do this, you simply bring times 1 over 2x, then du. As simple as that. So integral 2x square root of u all over 2x du. Obviously, this cancel this, and I'm simply going to have integral of the square root of u du, where this is the same as what? U to the power half plus 1 all over half plus 1, right? All plus c. Remember, this is the same as what? U to the power 3 over 2 all over here becomes also 3 on 2, right? So plus c. So this simply becomes your your integral by substitution. I have the second problem here for us to also solve. So the second problem says integral of 7 multiplying the expression 2x minus 1 x squared minus x plus 3 to the power 4 dx. So one may ask, when do we really use substitution method? Okay, so this is what we're going to do. We realize that the function I have here and the function I have here, I can't multiply or simplify it. It's difficult. This whole function is to the power 4. So expressing it to be difficult. Therefore, what you do is you compare that when I differentiate what is here and compare it to what I have here, is this the derivative of this? If yes, then you have to use substitution. So you can see that if I differentiate what I have here, I'm going to have 2x minus 1. Exactly what I have here. So let u be equal to x squared minus x plus 3, right? So my du on the x will simply be equal to 2x minus 1. As usual, you make the x the subject. The x will give me what? 1 over 2x minus 1 multiplying the u. Is that not it? I'll come back to my formula and make the necessary substitution as the method denotes. So 7 times what? 2x minus 1, right? Then this becomes what? This becomes u, right? So u to the power 4. Then the x becomes what? Times 1 over the expression 2x minus 1 du. So I can take this off like this, right? So integral u to the power 4, right? That is what I have here, u to the power 4. Then 7 is here, right? Du. 7 will go out, so I have 7 integral u to the power 4 du. And this gives me 7 u to the power 5 over 5 plus c, right? But what is u? We simply have to return u. So 7 multiplying u to the power 5. And we know that we made a substitution here as u to be equal to what? X squared minus x plus 3. So x squared minus x plus 3 all over what? 5, and here is 5 plus c. As simple as that. Yeah, so as simple as that. So this is the end of our